Welcome, everybody. So my name is Jason Fournier, and I'm passionate about databases, and I'll share that passion with you this semester. So as we will see, this lecture is called Information Retrieval. In a way, it's kind of the history of everything that happened all the way to ChatGPT and these large language models, so to give you all the historical perspective. And I will argue that it's a database course, because this is a kind of, we store data, we manage data, we query data, we want to retrieve information. So I would start with a question that I would like to ask you. So you're sitting with your friends over lunch, maybe in the Polymensa or Unimensa, if you prefer Unimensa. And then in the middle of a conversation, then a question pops up. You wonder, when Einstein was born. And maybe you try to guess in the conversation. I mean, this is how it was done in the good old times. And I would like to ask you, what would you do today when you are in this situation? So it's an opportunity for us to calibrate the Clicker app that is available at eduapp.ethz.ch. So you can use your smartphone, you can use your laptop if you want. The old Edu app is no longer in use, it's obsolete. So if you have it installed, you should just uninstall it. This is really in the browser that you have to go there. And it's just eduapp.ethz.ch, just this new address. So you can go there. And so you're in the middle of your lunch, you're wondering about something. Where do you go first? Maybe some of you will go to Wikipedia. Some of you might Google it on their smartphone. Some of you might Google it on their desktop or laptop, which might be around. Some of you might search on YouTube instead of a search engine. Or you might go ask a professor in the field. Have to go to the Hungerberg, though, because the physics department is a bit far away. Or you go to the ETH or computer science library. You run a simulation of the universe on a large-scale cluster, or you ask ChatGPT, Lusha, Perplexity, or any other LLM. So it's eduapp.ethz.ch, what you see up there. And once in a while, I will ask you questions like that. It's a way to participate, diversify a little bit the medium. Now, this is very interesting because actually I did not expect this. So most of you still Google or go to or Bing or DuckDuckGo or a search engine. That's very interesting because I had assumed somehow that the shift to LLMs had already started to happen. We still have 4 of you who would go to an LLM to find this information. All right. So let me go back to where we were. If I prepared everything correctly, normally we should every time land on the right slides. So indeed, you grab your smartphone and you Google. Maybe I was a bit optimistic and said maybe you also ask ChatGPT for some of you. So let's do it with Google because most of you actually would do it this way, right? So now that's the modern interface, right? You would type your question in there, even in natural language would just work. And then you have your answer. That's actually new. Compared to 20 years ago, you would still get the web pages. But now there is this feature that maybe was introduced 10 or 15 years ago that already attempts to answer your question before actually searching for pages that might help. So here you go. You actually directly have your answer. And then you have all sorts of widgets and displays that appear here. You have some resume, some summary. Well, it's kind of a resume in the case of Einstein right here on the side. Then you might have related queries, like some sort of recommender system that also wasn't there at the beginning. And then I didn't even put the web pages because they're down there, right? Which is, in essence, the purpose of the search engine. So people also ask, people also search for, that uses some kind of machine learning behind the scenes for that. Who has ever used Google as a calculator? Many of you, right? It actually works. Yes, you can type. It actually has an integrated calculator, even with buttons. You can actually start using it. And then, of course, it's still going to search the web and find related content. All right. So this has evolved a lot. And for some of you who actually want to ask an LLM, you can actually ask the LLM. Here it was ChatGPT. And you can even start a conversation and have a good time with the LLM, because it's actually more interactive than a search engine, right? It also works as a calculator, but don't push it because that's an LLM. It's good at literature. As soon as you start asking for multiplication and that kind of stuff, maybe it's not the right place to go. Well, here I assume that 1 + 2 is all over the place in text. So this is probably why it finds it out. In fact, so there is an LLM lecture at ETH that will teach you all of that. My goal is a bit to prepare yourself and give you the background. But hopefully with this course, you will understand why it's actually so difficult for ChatGPT to do math and also to count the number of R's in strawberry. This is another LLM. This is Perplexity, which is also on the rise. And this one is good at giving sources. So it's, you see Wikipedia, all kinds of places where it actually looked. Still have the related section over there. And here too, of course, it's interactive and you can interact, right? So this is 2025. Now, if we rewind a little bit through time, let's go back to 2021. In 2021, ChatGPT did not exist. GPT did. There were early models of GPT. They could autocomplete sentences in an impressive way, but ChatGPT didn't exist. So then we had Google, that was and all the search engine back then. If I continue to rewind, this is an older version of Google that dates back to the very early days, actually, in 1997, 1998, back then at Stanford. So they were studying there as PhD students. These guys, Larry Page and Sergey Brin. Just a question, who was born in 1997? Oh, wow. I was, but most of you are not. So this is time elapsing. This is the next generation every time. And so we will travel back in time way before you were born, and I'll tell you about some impressions from the 90s, 80s, and so on. All right. So these are the founders of Google. So it all started as the idea of trying to index the web and to download the web and index it in order to find pages. The revolutionary idea was called PageRank. It was all about how do you rank the pages to display the most relevant pages first that the users are interested in. This was an even earlier interface there before the logo actually started to stabilize. They even had this internal system within Stanford to search. But Google was not the first search engine. In fact, in the 90s, there were pre-Google, Alta Vista was really dominant. And in fact, it was not just a search engine, it was also a portal. You would have the news, you would have directories also. That's something that kind of disappeared. But there was a classification of web pages by categories. And one of the engines, I don't know, yes, I have it here. Yahoo was also a popular search engine back then. What made it stand out from the others, it's precisely the categories. This one actually categorized as many websites as possible. The internet was much smaller also back then. right? The web, even, I should say. All right. And then if I continue to go back in time, we have this. Whoever heard of Encarta? Some of you still. Okay, very nice. So Encarta was a digital encyclopedia. You actually, at least in the first versions, you would actually go to a shop and buy the CDs. And then you put the CDs into your computer, probably a desktop computer back then, more than a laptop. And then you open it, and all the information is actually on the CDs, which at the time was already impressive, right? That you would have so much knowledge on such a small disk, all local on your machine. And then you would open it, install it, and then you could also do some search. So it has a search functionality, and explore what is in here. Then Encarta, of course, with the web, it evolved a little bit, became a bit online. They set up a website. You could subscribe, pay some subscription. Then you get updates. The knowledge gets updated. And at some point, of course, with the web, you stop updating completely, and you just go to the web, right? This is the ultimate permanent update, right? But back then, again, it was local. It was on the machine. Everything stored on that little disk, and you would search for that. This is actually not so old in perspective. The web, it dates back to 1989. It was actually invented right here in Switzerland, in Geneva, at CERN. That you might have heard, right? Sir Tim Berners-Lee, who heard the name? Right, some of you. He's the inventor of the web. And it's a very interesting story because when he actually wanted to publish his work, so the idea that he had is a combination of the internet and what is called hypertext. Hypertext is this idea of having, like back then it was blue and underlined when you click. That's called a link. That's what is called hypertext. And then this idea that when you click, you go to another page. And he basically built an integrated system that allows you to navigate in this way, right? So this is how HTTP and the web was born. But when he submitted it to a conference, they actually thought it was not really that interesting, and he was only allowed to present a poster in some corner of some building. And of course, nobody would have known back then that that was actually going to be an enormous revolution for the whole world, right? No, I'm going back. Yeah. So now if I go even further back in time, before we had the web and the computers, typically, the knowledge was stored in the encyclopedia that look like this. Who has one at home, or maybe their parents or grandparents, right? So that was in many people's homes, right? You would have 20 or 30 volumes, all sorted alphabetically. It's like a giant dictionary, but instead of just the definitions, you have maps, you have plenty of pictures, you have plenty of explanation. And then you had these at the end. This is an index. This is when you specifically look for some information, and it basically points to all the others, right? So you have indices without computers that already existed in the form of books, right? So you look up the word alphabetically in there. Now, there is an obvious problem with these, is that they do not update. You cannot subscribe to anything. You just have to buy a new one, which obviously is very expensive. So people did not just go ahead and buy them frequently. But this was one of the drawbacks at the time, that the web and new technologies actually solved. So now I'm going to do a huge jump backwards in time. So if we jump to, let's say, the beginning of humans, this was roughly 3 million years ago, right? The first humans. But in fact, the modern times in which we actually started settling and having an economy was only 12,000 years ago. And that has to do with the fact that things warmed up a little bit, right? So basically, we are in the middle of a big ice age, and we are in an interglacial period that started 12,000 years ago. And so when that happens, then humans started settling, agriculture developed, and so on. And so this wasn't 12,000 years ago. That was maybe 2,300 years ago. the Library of Alexandria, it's an example of back then, people already attempting to build these repositories of knowledge. So of course it was very expensive to do, and typically that was driven by emperors, kings, queens, who financed all of this. And so the Library of Alexandria is an example of that. You probably heard of Alexander the Great, and then there was Ptolemy the First, and then Ptolemy the Second, the son actually founded this library. So back then we didn't have books. We had papyruses, we had scrolls, you know, that was stored in there. And so there's interesting anecdotes about what happened at the time, is that the obsession of knowledge was so strong that whenever there was a ship that would arrive in the harbor, the king or the queen would give the order to go to the ship and search for knowledge, for papyruses, codices. Codices is the old name of the book. I'll come back to that. And take them, copy them, because of course we didn't have any printing press. Gutenberg didn't exist yet. So they copied them, and then they kept the originals and brought the copies back to the ship. And the ship had to live with the copies. So that was this obsession of gathering knowledge. One of the reasons was that the copy might have mistakes. So if you take the original, then there's less mistakes. Another anecdote about this is this library also had dining rooms, living rooms, so plenty of spaces, and tried to attract people from all over the world, so other countries. Typically not so many, actually maybe 20, 30, and they would go there, they would read, bye-bye, just before you leave. So this is Juan, he's one of the assistants. He just has to leave early. I will introduce everybody later. Thank you very much for coming, Juan, and see you later. Yeah. So the libraries tried to attract people from all around the world that would just live there. They would read, they would write new texts, they would have interesting conversations about philosophy, about all sorts of things. And so it was in fact, some sort of mini university, right, in the early days, so a place of learning. Then if I start moving through time, so these are codices, so that's the Vatican Library, 15th century. What codex means, actually, it's just the ancestors of books. It's the idea that before on papyruses, you had the sheets of paper, but they were not bound. And then there was the idea of taking sheets of paper and binding them. And this is how the early ancestors of books were born, that you have then plenty of pages. And of course, that's still before the printing press. So the only way you can replicate this is by manually copying them over. Then if I continue to go through time, that's the Herzog August Bibliothek, 1661. Back then it had 116,000 books. Bibliothek, by the way, comes from biblion, Greek, book, and tek is the place where you put them. Then we had the British Museum, that's the 19th century, 240,000 books. So you see it keeps going up. The Library of Congress, that was 1990, had 100 million documents. Documents, not just books, also audio, video, like all sorts of things, even digital documents, but 100 million documents. The second largest library today is in Shanghai. It's the second largest and the second tallest. It has 24 floors, 24 floors. The tallest one is Jakarta in Indonesia, even taller, the tallest in the world. And the largest by number is the British Library, which you see here. So of course, when you have 100 million books and you don't have computers yet, how do you manage to index them? Well, it's a bit similar to this idea of what you have at the end of the encyclopedia, that you need to build alphabetical list with some pointers. But one of the ways to scale this was the Dewey Decimal System. It looks like this. I actually went before the course to the computer science library hoping that I would find one of these posters that they had. It seems it doesn't exist anymore. So this is maybe something that, because of the computerized system, is no longer in use. But whoever saw this 3-digit classification numbers. Some of you, right? You often see them. It's the way it's organized in libraries. And the idea is that these are categories, so very generic categories. Of course, it was done before computers, so the size for technology and so on is rather small in there. But you see philosophy, religion, social sciences, languages, natural sciences, applied science, arts and recreation, literature, history, geography, and biography. And then you had subcategories and subcategories. And so if you went to a library, the books would be organized according to this classification. This is how you get all the history books at the same place and so on, right? All nicely sorted according to this system. So that's called the Dewey Decimal System. Then things started to become also a bit more complex. So there's the notion of Verschlagwortung. In German, it's the idea of trying to classify the information in order to be able to find the books you're looking for. So this goes beyond just the three-digit systems. It's the idea of organizing even famous people, concepts, ideas, and so on, so that you could find the books that are in this area. Now, the idea of automating this with systems is actually already present in the 1940s. Almost a century ago, maybe not quite yet, 80 years ago. It's actually Vannevar Bush who had this idea of some desk-like structure that you sit on, and then you just press buttons or enter stuff in such a way that you get the information that you look for. So of course, back then we didn't have the transistors and semiconductors, so the way people thought of automation was more in a mechanical form, which is how the early computers were actually built. This is why you see all of this. But if you think of it, that's actually a smartphone in a way. It's just the very early idea of an information system that works in this way. So this is Vannevar Bush. He was a visionary for a second reason that I will show you very soon. He also saw something else coming. I prepared a second clicker question for you. I think it's yes, this one. Just to understand your background, I assume computer science is going to be by far dominating, but we also sometimes have visitors that we welcome from other departments. See a mechanical engineer. Two mechanical engineers. Three. An electrical engineer also, ETH. All right. Okay, so as expected. So most of you are bachelor students in computer science. Just out of curiosity, who is a third-year bachelor student? Second year? Already visit now? Okay. Who is right now taking the Introduction to Machine Learning lecture? Okay, half of you probably. Who is already so impatient to learn that they're already in the LLM lecture, the master's level 1? Okay, very good. So my goal is that you will have enough introduction that maybe next year or next in your master's, you can follow this lecture, which of course goes much more into the formalism and the details, right? So this lecture here is more of the history of what led to LLMs. Okay, so that helps me understand your backgrounds. If I did everything correctly, this is how we get back to where we were. Okay. Also a note in general, so we have people on Zoom who are watching us right now. And we have George right here, who is one of the TA. He's moderating. He's making sure that I don't miss any questions. You see, so you can raise your hands in the lecture hall. On Zoom, you can write your question in the chat, and George will interrupt me, and I'll address the question to make sure that also on Zoom you're included in the lecture. So do not hesitate to ask questions. I might not know the answer. I mean, I'm also learning. So, and we are in a university, so it's absolutely okay to have questions and to not know everything. Right. So let me continue a bit. Still history, but this time not history of books and libraries and encyclopedia and the web, but more the history of databases. I'm going to start with prehistory. So history and prehistory, classically people think of the invention of writing, right? This is the date where we started having written stuff. For databases, it's actually 1970, the turning point. So now if you go very far in the past and ask, how did we transmit data or information? Well, back then, we just had to speak and sing. So what happened is that it was transmitted from generation to generation just by word of mouth. The songs were actually useful because with a song, it helps to retain, to memorize the knowledge. And this is how also it spreads in the population. So the songs actually played a role for this. So speaking and singing. But there is a problem if you transmit information with speaking and singing. Because you can distort information, you might forget information, and you can no longer rely, maybe 3, 4, 5 generations later, maybe the information has changed and it's no longer faithful with the actual events. This was solved with the invention of writing. This idea that we could encode in some way the information on some durable medium that is going to be there for thousands of years. This is the reason why we can still see this information today, right? Because it actually lasted for thousands of years. It doesn't mean it was easy because, of course, we still need to figure out the encoding that people used at that time. Some of them we were able to. That's the Rosetta Stone here, with which we deciphered the Egyptian symbols, hieroglyphs. Some of them are still unsolved. There are a few alphabets and languages that we are still not able to parse today, so we don't know what there is in there. But this is changing because now with artificial intelligence, there were recent discoveries made in the past years of suddenly with an AI, we were able to figure out the meaning of the symbols. So this was one of the ways that people could write. There is another one. And this I find mind-blowing. Because when you look at this, I don't know if you have the same impression, but it feels like an iPad that is thousands of years old. Like this is a clay tablet, and it even has a relational table, right? This is a spreadsheet literally in front of your eyes. Thousands of years old. What there is in there, we know what there is. It's actually numbers that are integer length of a right triangle. You know, like 3, 4, 5. There's no 3, 4, 5 here. It's higher numbers, but these are all the integer size of a right triangle. And there are mistakes, and we know where the mistakes are in there. What that tells us is that tables are incredibly intuitive for human beings. They have been intuitive for thousands of years. Right? So this is the lesson that we learn here. And so this is the reason, I'll come to it in the history, but this is the reason why we have relational databases in this shape. Then there was another revolution, the printing press. The printing press solved the copying issue. How do you propagate information in thousands or millions of copies without having people that manually do these copies, which was done before, typically in monasteries and these kind of places, right? So now we solved it. We can really, you know, this is why it's called Buchstaben. Buchstaben actually in German is because we actually had Buchstaben that we would put, and then with ink, it would just go on paper. By the way, uppercase, lowercase, the reason we call it uppercase, lowercase, has to do that these Buchstaben were in a case, and in the upper part, there was the großgeschrieben, the uppercase, and the lowercase, the lower part of the case, had the lowercase letters. So this is also for historical reasons. Then we had computers. Computers accelerated the processing, first mechanical, then with semiconductors. What is funny is that this computer that you see right here and that if you switch it on, the electricity disappears in the city because it's too much energy, is much less powerful than the smartphone in your pocket, right? So this is the progress that we've made here, right? They filled entire rooms at that time. And so we arrived in the 1960s, and in the 1960s, we were in a state that we could store the data as files inside directories. So this is the file system as you know it today, right? Maybe you don't see it on the smartphone so much because it's less exposed, but on the laptop or the desktop computer, you see this file system. And so in the 60s, people would store their data in there with files, and they would use computer programs to parse these files and open them and process them. Maybe it actually sounds like Jupyter Notebooks and Python, which is kind of backwards in terms of where we are going, but I'll come back to that, right? But anyway, this was considered not satisfactory that we had to open files in this way, which is why Edgar Cott in 1970 had a brilliant idea, which was to say the users shouldn't even have to deal with files and directories. That should be hidden from them. All they should have to deal with is tables. Who already took the database management and modeling class? Many of you. Who is taking it? Oh, it was, okay, yeah, I think it was last semester, right? It was last semester, all right. But many of you have this knowledge, right? So this is what you learn in this lecture. So we have relational tables and data independence, which means that we hide the complexity of the files and directories and just look at tables with rows and columns. Then in the 1980s, we had the first object-oriented languages, C++, Java arrived in the 1990s, which shifted the programming paradigm. And then people tried to connect them back to databases. There was an impedance mismatch between objects and records in a relational database. So there's a whole bunch of technologies that were designed for that. Then in the 2000s, we had the problem that we just had too much data and it was too messy, so we just couldn't fit it anymore in tables. And this is why we had key value stores, triple stores, column stores, document stores. By the way, it might not feel like it, but key value stores was the ChatGPT of the time. When key value stores got out, everybody wanted a key value stores. Everybody wanted to install a key value store and push the data in there. Right? So that was a very, very big buzz at the time because of the scalability. Even if they didn't need it, because what they really needed is a relational database. The same can be said about the blockchain. Many people who think they need a blockchain actually need a relational database. All right. So because of this size came big data, and here is just a bit of a quick overview of it. There's a lecture dedicated to that you can take next year. But we will be a bit in big data because we will try to scale the information system that we built, the information retrieval system, right? So we'll have a bit of MapReduce and of scale in one of the weeks. So the first thing is that you need to know these prefixes. Who already knows them all? Okay, you have to, right? You really have to learn them. So the first ones you probably already know. Tera, peta, hexa, zeta. Think of the Greek tetra, penta, hexa, hepta. That's how I remember them. So tetra is 4. There's 4 groups of 3 zeros, right? Rona and queta were more recent because we ran out of zeros. And so we had to come up with 2 new prefixes. That was just a couple of years ago because of the weight of Jupyter, that we didn't have enough zeros in the prefixes. So you should learn them. That's really a must. Especially the last, maybe the last 4 that you might not know. So that's the first thing, it's the volume, the quantity of data. The second thing is the variety of data. Because while tables were for thousands of years the most popular way of visualizing data, we also have trees. And the fact that people had files and directories kind of also hints that the tree structure is kind of also important. So here I have in mind XML, JSON. Then you have graphs. Graph databases are actually also quite buzzy today with Neo4j. We have cubes since the 1990s. So this is the slice and dice and all the sales reports that you get to the C-level executives in companies. And then we have text. That will be what we will be interested in this lecture. But in fact, text is increasingly starting to look like vectors, vector databases and so on. So we'll touch a little bit vector databases and the vector space model and so on. It's actually been there for a while, but because of LLMs, vector databases are actually now also on the rise technologically, and they are being massively improved in terms of efficiency to support systems like ChatGPT. And so these are the shapes of data. Almost all systems today fit in one of these shapes: tables, trees, vectors, graphs, and cubes. Maybe there will be new ones, but it's really not so often that we have a new kind of shape. Typically, it's within these 5. And so you can classify them from unstructured to structured. So vectors are basically, that's how you process text. So this is highly unstructured, can be text, can be images, videos, audio. Then you can structure it a bit more with graphs, trees, even more structured, and tables and cubes. This is the most structure that you can ever get in the data, right? So this is the spectrum of data structure, right? So when people say semi-structured data, very often they have XML and JSON in mind. It has to do also with denormalization, the fact that the data is not going to be in normal form, right? So be prepared. We taught you the normal forms in the database modeling lecture. Next year, we're going to throw them away because at large scales, you actually do not want the data to be in normal forms. Okay, but in this lecture, we are going to focus on unstructured data because it is on the rise, right? This is the internet, the texts that are produced, all the data that goes right into the AI systems. So we have text, we have pictures, we have audio, we have sounds, we have all the activity on the internet, so on social media and so on, so micro blogging platforms. We have video, that's one of the early ones where, I don't know if you know what's going to happen here, right? So some water is going to just pop out of this. So the idea of unstructured data is that it's in a very raw form, and the structure is actually not explicit as it would be in a table, it's implicit. So you need to find features. This is what machine learning is all about. You need to find the features so that you can make predictions, right? So it means that it requires a bit some extra efforts to extract the features of these things, text, audio, video, and there's not only one way to do it, there might be different ways of doing that. Based on characters, as we will do in this lecture, with tokenization, grammar, pixels, waves, so whatever you want to extract, maybe with Fourier transforms, that sort of things. So the idea is that we have a gap here, and that has been bothering philosophers for centuries already. It's the gap between information and the representation of information. This is the reason why it's so hard to decipher these old texts, because we see the characters and in front of us, but we don't know what they mean. And so in order to understand something, you don't only need the syntax of the information, you also need some extra context that tells you how you have to understand that syntax. And this is the gap that we have here. And one of the challenges behind information retrieval systems and LLMs. There are a few words that we consider to be in some form of a progression or hierarchy, which is data, information, knowledge, and even wisdom. So what we call data is really the raw data with the syntax, the bits, and so on. When you start to add so what's in the middle here and extract meaning, then you get what's called information, as in information retrieval. And then when you start having a meaningful application and you apply it, that becomes knowledge. And then you have wisdom. That is when you even know when and when not to apply the knowledge and which to apply. All right? So that's for the terminology, data, information, knowledge. You might see those in context. So that's for variety. And then we have volume. Volume, it grew a lot. This was a computer on which the web was demonstrated. Now we have plenty of repositories. So this is a financial repository with it's called the time series. It's also an interesting database problem, how you store and manage time series. We have academic publication platforms like archive.org that keeps growing. They used to have 4 digits every month. Now it's 5 digits because there's more and more published there. It even extended beyond physics to computer science and other fields. We have shop repositories. After all, Amazon or Digitech Galaxus, these are all repositories, right? It's just millions of references and products that you can buy. Again, the social media to share pictures and so on, these are also repositories of information because you need to store the data that the people put in there, index it, and make it easy for people to search it and find it. So it's also an information retrieval problem. But what I want to come to, it's going to be exactly synchronized with the break with a cliffhanger, hopefully, is the evolution of three factors in the past decades. These three factors are capacity, throughput, and latency. So here's what I call them. Capacity, I call the amount of data we can store, typically in bytes, megabytes, gigabytes, terabytes, like the capacity of a hard disk. Capacity. Throughput, I call the speed at which we can read or write data. So here we are talking about bytes per second, megabytes per second, right? So it's the reading and writing speed of the data. And then we have the latency, which is in seconds or milliseconds or nanoseconds. It's when do you start receiving data. Now, some other people consider that the latency is when you are done receiving the data, right? So they measure it unto the end, right? But here I'm going to use it with the convention that it's when you start receiving data, right? So if I look at these three things, so capacity, throughput, latency, so I digged a little bit and tried to find the oldest hard drive ever that was commercially available, that you could buy. And I found it in 1956. That was the IBM Ramac 350. And you see it on the screen. It has all these disks, so they look like this, the disk, but they are on top of each other. Had an incredible capacity of 5 megabytes, 5 million of characters, because we didn't have UTF-8 back then, so a byte was kind of a letter, a character. The throughput was an amazing 12.5 kilocharacters per second, so 12,500 characters per second that you could read. It has to rotate very, very fast, of course, for you to do that. And the latency was 600 milliseconds. Why the latency? Because the way that these mechanical drives work is that you have some sort of reading head somewhere, and you need to rotate this and bring it below the head to read. So that needs time for this to rotate all the way here. So this is why the 600 milliseconds. Now we have the luxury of SSD and flash drives and so on. So of course that kind of goes away, as we will see. But back then we had to let these mechanical parts rotate. By the way, this is why it's actually noisy. When you have an older laptop that has a mechanical drive, you can hear it, all the noise that it's actually making. But I kept the best part for the end. It's the dimensions. The dimensions are like this. It's absolutely enormous. We are looking at 1.70 meters times 1.50 meters times 70 centimeters. This is how big it was. And all of that just to store 5 megabytes. Now you can actually fit millions of them just on your laptop. That's actually quite impressive, but let's try to quantify that. So I try to find now the largest drive. So basically the descendant of that, the largest ever that I was able to find was this one. It's the ExaDrive EDDCT100, but I have to zoom in a little bit, and it had an incredible capacity of 100 terabytes. 100 terabytes. And that's actually a huge jump because it used to be, even in the last lecture, I was at 20 or 30 terabytes. Now we have 100 terabytes. Throughput, 500 megabytes per second. Megabytes per second. It's an SSD, by the way, solid state drive. It's no longer mechanical. And that's why the latency is now 0.1 milliseconds. That's thanks to the solid state drive that doesn't have these moving disks. Dimensions, you know, right? These are the dimensions. It's a 3.5-inch drive, and you have some with 2.5-inch, even smaller than that. But why am I doing that? I'm showing you the capacity, the throughput, the latency. What I'm interested in is the evolution of these between the IBM Ramac 350 and the ExaDrive EDDCT100. And so I plotted it. This is the evolution of the capacity per unit of volume. I renormalized to account for the size, so it's the number of bytes per cubic centimeters, let's say. And then the evolution of the throughput and the evolution of the latency. Now you might think I have to click here to make the throughput and the latency appear. No, they're already there. This is the evolution of the throughput and the latency compared to the evolution of the capacity. So the conclusion here is we are in big trouble. We are in big trouble because now we can store gigantic amounts of data, but we cannot read them fast enough. This is a huge issue, right? And that's the cliffhanger for the break. And I'll continue in 15 minutes at 11:15. Thank you.